Here we go with our 2.3.5 notes. Let's start with some review of 2.2.4. So we're working with the quadratic formula here. So give us a try on your own, then pop back in for the solution. Okay, so when we simplify, we want to simplify under that root. So 6 squared is 36. Negative 4 times 1/2 is negative 2, times 9 is negative 18. All over 2 times 1/2 is just 1. So we have negative 6 plus or minus. 36 minus 18 is 18, so the root square root of 18. 18 is not a perfect square. That does not mean we stop. We look for perfect squares that factor into 18. So I know 9 times 2 is 18, so I can write the square root of 18 as the square root of 9 times the square root of 2, which would be 3 root 2. And that's it. Okay. So the focus for today is on the discriminant. So let's revisit our 2.0 target as relates to the discriminant here first before we move on to that 3.0 skill. So it says use the discriminant formula to find how many solutions each of the following quadratics have. So remember, our formula for the discriminant is b squared minus 4ac, where a, b, and c are the same a, b, and c they've always been. A is our number with x squared, b with x, c on its own. So when we plug those in, we'll have negative 2 squared, because negative 2 is b, minus 4 times an a value of 1, times a c value of negative 3. And then we simplify. So negative 2 squared is 4. Negative 4 times 1 is negative 4, times negative 3 is positive 12, so we get positive 16. So remember, when your discriminant is positive or greater than 0, you have two x-intercepts. So if I have two solutions, or two x-intercepts, my answer was greater than 0, or positive. See the next one. B squared, so negative 6 squared minus 4 times 1 times 9. 1 for A, 9 for C. So negative 6 squared is positive 36. Minus 4 times 9, so minus 36 is 0. So our answer is 0. When we have 0 as our discriminant, we have one x-intercept. So if I have one solution, my answer was equal to 0. Last problem, you can probably see where this is going, but 3 squared minus 4 times 1 times 3, so just plugging in a, b, and c. So we get 9 minus 4 times 1 times 3, so minus 12 equals negative 3, which is less than 0. When your discriminant is less than 0, you have 0 x-intercepts or 0 solutions. So if I have 0 solutions, my answer was less than 0, or negative. Okay. So we want to keep these facts in mind as we're working on our 3.0 target. So let's look at a problem first to begin. So it says given f of x equals ax squared plus 9x minus 4, find all values of a which would make this quadratic have two solutions. So we're trying to figure out what values of a, what a has to be to make it have two solutions. So let's first think about our discriminant. So b squared minus 4ac. So how does that relate to 0 for us to have two solutions? Does it need to be greater than 0, equal to 0, or less than 0? For us to have two solutions, our discriminant must be greater than 0. So let's plug in what we know. So we know b is 9, we know c is negative 4. So we'll have 9 squared minus 4 times a. We don't know a yet, times negative 4. 9 squared is 81. Negative 4 times negative 4 is positive 16, so I have 16a. And as I'm looking here, we basically have an inequality we can just solve for a with. So let's subtract 81 from both sides. Divide both sides by 16. And we get a is greater than negative 81 over 16. So what this is saying is that whenever a is greater than negative 81 over 16, our discriminant is going to be greater than 0, which means we have two solutions. So all a values that are larger than or greater than negative 81 over 16, those would be our a values that make us have two solutions. So this would be our answer. So you use your discriminant, figure out how it needs to relate to 0. Remember, if it has 2 solutions, it's greater than 0. If we have 1 solution, equal, 0, less than. And then you go ahead and solve for your variable. So let's try another together. So in this case, it says we're missing b. So it says given f of x equals 3x squared plus bx plus 2, find all the values of b which would make this quadratic have 1 solution. So for us to have 1 solution, that means our discriminant must be equal to 0. So let's plug in what we know. We don't know b, so we'll leave that as b squared. We know our a value is 3, and our c value is 2. From there, let's try and solve for b. So negative 4 times 3 times 2 is negative 24. Add 24 to both sides, we get b squared equals 24. We're solving for b and we have b squared. So how do we cancel a square? Well, we do so with the square root. So we get b equals the square root of 24, which we can simplify square roots if possible. So 24, thinking about what perfect squares factor out of 24, well, I know 4 times 6 is 24, 4 being a perfect square, and the square root of 4 is 2. So 2 root 6. And in this case, notice it was equal. So our solution would be when b is equal to 2 root 6. Okay. All right. So we got 3 more problems. I think we could go ahead and give those a try on your own. I'll still be going through some solutions with you, so you can pause it, give these 2 a try, and then we'll move on, talk through them. Okay, we're back. So we want a quadratic that has no solution, so that means my discriminant's got to be less than 0. So let's plug in what we have. We know b is 4, so that'll be 4 squared. Minus 4 times a is negative 2. We don't know c. Negative 4 times negative 2 is positive 8. And 4 squared is 16. Subtract 16 from both sides, we get 8c is less than negative 16. Divide both sides by 8, and we get c is less than negative 2. Okay. For b, find all values of b which make it have 1 solution. So b squared minus 4ac's got to equal 0, so let's plug in what we know. We know a is 1, we know c is 5. So we get b squared minus 4 times 5 is 20. Add 20 to both sides, we get b squared equals 20. Take the square root. We get b equals the square root of 20, which we could rewrite as the square root of 4 times the square root of 5, which would be 2 root 5, or b equals 2 root 5. Okay. The last one, you can pause it and give it a try. Okay, we're back. Find all values of c, which would make this quadratic have 2 solutions, so that means my discriminant must be greater than 0. So we have b is negative 2, a is 3, c we do not know. So negative 2 squared is 4, minus 4 times 3 is negative 12 times c. Subtract 4 from both sides, we get 12c is greater than negative 4. Divide both sides by negative 12, we get c, and then negative 4 divided by negative 12 is 1/3. Remember, when you're multiplying or dividing by a negative with an inequality, gotta flip the sign. Careful there. So remember, multiply or divide by a negative, flip the sign. Okay, and there we have it. That is it for our 3.0 target.